Hello everyone, good morning, good afternoon, good evening. This is Sriram here. I am from the Tech Advisor team of HCL Automation Orchestration Suite. Today we are looking at a banking use case. This is around monitoring fraudulent transactions or suspicious transactions and then detecting them as anomalies, sending notifications to the customer, deciding whether to block the transaction accordingly, and then taking it forward also and comparing with the historical data. So, this is the kind of flow that we are looking at. We are reading a continuous stream of transaction from the AWS SQS service, and once we detect that a transaction is out of place or maybe is slightly suspicious, we take it through an AWS Lambda function and then decide if this is an anomaly or not. If the transaction is detected as an anomaly, we send a notification to the customer through an AWS SNS service. And then we also, at the same time, we are also uploading, blocking this transaction in case customer decides to decline the transaction. And in case, or that could also be a case where he's accepted the transaction to be normal. We would be uploading all the, we would also be querying all the historical data in an on-prem DB, which would be in the core banking application of the bank. And then we would also be extracting data from the core banking DB, and we'll be transferring it to an AWS S3 bucket. We'll also upload this particular current transaction to the AWS S3 bucket. Of course, here care is taken when working with AWS services where you only take the transactional data without disclosing any customer personal information. All customer personal information is still stored in the core banking DB. There's a machine learning algorithm that's trained. Again, this is a Python program that we run called through an AWS Lambda function. And then, based on the current transaction data and the historical data, there are behavioral models that are built to take into account the learnings from the current transaction and also take into account the customer behavior of the from the current transaction, and also taking into account the historical data. The model is updated. Now, there's also another step here, if you notice, where we are also provisioning VMs. So, of course, we can provision AWS EC2 instances or have CloudFormation templates to deploy this on Kubernetes and have the model deployed there and then run dynamically. But for the this particular use case, we are not looking at this portion, and we are going to do it directly on already provisioned serverless in a serverless way via AWS Lambda. So HCL Workload Automation, as you know, is a leading workload automation product, not just um, historically, but also in the current uh, MR Radar report, where we have been rated as the best AI-assisted automation product. Now, this is the workload designer interface where I have this particular uh, flow wherein I'm realizing the same flow that we just now discussed, uh, wherein the first job is going to look for continuous stream of messages from an AWS SQS service and is going to run in an event driven way where it detects a particular message, it reads the message from the SQS service, it's going to send a notification through an AWS SNS service to a customer, indicating that this particular message was received, or this particular transaction looks suspicious or looks like an anomaly. And then we're going to have another job that is going to extract the historical transactions from the DB. This is going to hit the core banking database and get the historical transactions of pertaining to that particular customer. At the same time, we have three jobs which are going to get the account number, the transaction amount, the transaction type, and are also going to upload all the historical transaction data and the current transaction data to an S3 bucket. This particular job is then going to compare or build the or is going to analyze the anomaly again, in through AWS Lambda function, where we'll be taking the current transactional data and the historical data into account, and also the current customer behavior into account. And then finally, there are behavior models that are built based on the data that is fetched. So this is the kind of flow that we are looking at. Assume I sent a particular um, message through an AWS SQS service. Now, as you can see, there is a um, delay before this transaction can be analyzed. We have a 15-second delay. And I'm going to submit this particular job stream that's then going to analyze this particular transaction. Now, what we are sending here is, of course, the name that is masked, the account number of the customer, the transaction amount, and the type of transaction. Now, this will be received as a continuous stream in real time, whereas we are simulating a transaction here. Now, let's say I'm going ahead and submitting this flow, which is going to be submitted in an event driven fashion in real time. So, what happens in the background is this particular flow, when submitted, is going to analyze this transaction. So, it's going to start. From the first step, that is going to read from the SQS service. So this is a AWS SQS job that's reading from a queue. It's retrieved the message and it's stored it in a particular file, output file, realized directly as an AWS SQS job. There's another job that's going to also call an SNS service, and it's going to notify the customer that this anomaly is detected. Now, what the customer would do is decide whether to decline the transaction or accept the transaction. At the same time, we have a set of series of jobs that are getting the account number, that are getting the transaction amount, that are also getting the transaction type. And once this info is fetched, we are also extracting all the historical transactions of the customer from the DB, from the core banking DB. Now, the historical transactions that are extracted are uploaded to a AWS S3 bucket. So there's an AWS S3 job that's going to upload this to a bucket through a module that is run in a serverless fashion. And at the same time, we are also uploading the transactional data uh, directly to an S3 bucket. Finally, we have a job that is going to look at the input from the anomaly transaction. Is going to run a function that is going to look at the transactional data and also the historical data, and decide if this particular and also further learn from the current transactional data, and is going to build a model. So we're going to have another AWS Lambda job that's going to build a model and then decide then build on this particular model based on the current transaction and historical data. So we have the whole flow realized end to end within HWA. So everything from the anomaly detection to also talking to each of the AWS services, to also hitting the on-prem DB within the core banking database. So we have a product that is going to talk across all the AWS services, and is also going to run steps within on-prem side of things, and is going to amalgamate everything and realize and give you that end-to-end visibility, wherein you know that whenever there is a suspicious transaction, at what stage the suspicious transaction, what stage the analysis is in, and also go on building on the AI model, so that the behavioral model is in tune, is in line with the customer behavior, so that it's also a self-learning model, wherein the model can then also build on the historical data of not just all the historical transactions, but also the taking into account the current transaction at hand.